Welcome to another video and Happy New Year to everyone. In this video I want to start a little project that I'm looking to continue throughout the entire year 2025, and that is to see how well I can possibly do on what can be considered the 101 in machine learning, which is the competition on the Titanic dataset on Kaggle. So my plan is to use KNIME and the various built-in functionalities like decision trees, random forest, and so on and so forth to see how I can improve my submission and how good of a score I can get. But let's briefly look into what the challenge is about. So the Titanic challenge is about a dataset that contains information about the passengers of the Titanic, which sunk, and whether the passenger has survived or not. So that is the survival column, 0 for no, they didn't survive, and 1 for yes. There are a bunch of other columns like the ticket class, the gender, age, and so on and so forth. And based on this information, the goal is to train a machine learning model that predicts for a test data set whether each passenger survived or not. And there's a leaderboard for that. 1 is a pretty much best score. Not sure how these guys did that. There are a bunch of them, and there are 14,669 submissions so far. In today's video, I will walk you through how you can use a simple decision tree model to optimize your submission. Let's get right into that. So in KNIME, I've already prepared the data. In total, you can download from Kaggle 3 CSV files, the training set data set, which is the data that we are using to train the model, the test data set, and also the submission structure. So here are 418 records, and for each we need to add a prediction column whether the passenger survived or not, and then we need to cut it down to just the passenger ID and whether they survived or not. And these are the actual results as well, so we can use that to evaluate how good our predictions are. But let's start with looking at the training data set. For machine learning, it's important that the data is as clean and as concise as possible. So what I like to do when I get a data set is I like to explore the statistics. And in particular, I look at these two columns, the missing values and the unique values. And to start with the missing values, we can see that there are 177 records where the age is missing, so we need to find a way to handle that. And then there are 687 records where the cabin is missing. So we also need to think about how to handle that and if we have to handle that. My first thought is for this first submission to keep it very easy. So for the age, my strategy will be to just use the mean age, and for the cabin we'll look at that in a bit, but my idea is that we keep it very simple and maybe just keep it as an unknown. It's not guaranteed that we really need this column for our prediction. So let me add some notes for the pre-processing and walk you through. So to start with, we add a missing value node. And what this missing value node does is, if I inspect the column settings, we replace in the cabin column anything that's a missing value with a U for unknown. And in the age column, we will go for the median age for every missing record. So then, if we inspect the data set, you can see that there is U and then C85, C123, and so on and so forth. And in total, if we inspect the statistics for the cabin, there are 148 unique values. So after reading through the data set, it appears that the letter indicates the deck that they are on. So in order to reduce the dimensionality of this column, I will only keep the letter. And that is being done in the expressions node. So it just keeps the first character in this column. And to be honest, I didn't come up with this myself. I mean, this isn't too hard, but I'm a big fan of using KAI for something like that. So if you have that extension installed, you can click this button. That will prompt you to log in to your KNIME account. And once that has happened, you can describe your task. So I just asked it here, only keep the first letter of column cabin, and this is the outcome. Then you can test it by clicking on evaluate rows, scroll over, and you see it worked as expected. So next, I played around with which columns to keep. I found that the most predictive columns are the class, the sex, and the age. So in the end, I didn't really need the cabin for that. And then the next node is to turn this survived column from integer to string, because that's what our decision tree node will need as an input. After that, there's a partitioning node, and this partitioning node just randomly draws samples from this data set and puts 80% of them into the top port. So that will be our training data set, and 20% in the bottom port. That will be our test data set that we will use the model that we've trained on to see how well it's doing. So next we are already getting to the juicy part where we are going to train a model. So there is this node, the decision tree learner. And if we inspect that, there is a class column to be put in, and that is a class that we want to predict. So we want for every passenger to predict whether they survived, which is a 1, or did not survive, which is a 0. Then there are a bunch of different settings. We won't go over them. What I will try and do is to optimize the based on the minimum number of records per node in the decision tree in the very end. So before we execute that, let's keep going a little bit. We can then also visualize this decision tree, and let's maybe train one for now. I just have to remove the number of records for now. And in this decision tree learner node and decision tree view node, we can then see what the decision tree is. So the way you read that, it looks at the gender and then puts create this tree branch for males and the other for females. Then it looks at the age, where it's larger than 6.5 or smaller and equal to 6.5. And for those, it then looks at the class and so on. And if you click all your way through, you get to these leaves that tell you that there are 9 people in this leaf where the prediction is that they survived. So how do we use and evaluate this model? We add a decision tree predictor. So the output of this learner is a port that connects to the predictor, which is the machine learning model. And then we put in as an input the test data set. And once we execute that, we get this prediction column on whether they survived or not. And with this, we can then send it to a scorer node because we have the prediction as well as the actual result, whether they survived or not. So with the scorer node, we can select the first column, which is survived, and the second column, which is the prediction, and execute that. And that gives us a table that tells us out of 116 people, 101 did not survive, and that was predicted correctly, and 15 that were predicted to not have survived. And the same is for the ones that survived. So 24 that actually survived were predicted as not survived, and 39 that survived were predicted to survive. So this is obviously not a very good score, which is why the next step is to try and optimize that. So for that, there is a very useful parameter optimization loop. So what this loop allows us to do is, in this start node, to define certain parameters, and that can be 1, 2, or whatever. And in this loop, then every combination of the parameters, so in this case, it will start with 2 and finish with 15. So that's 13 different runs. It will train a model, test it, and then tell us at the end which parameter resulted in the best score. So this creates this variable minimum number of records, which I will now go to the decision tree learner and set as a flow variable. So this flow variable makes sure that first the value of 2, then 3 in the next one, 4, and so on and so forth gets passed to this parameter, and one model is trained per run. And at the end, we are collecting the one that has the best score. This now tells us that the highest value that we could achieve was 0.688 with a set of minimum records of 6. So with that information, let's now add pre-processing to our test data set, because next we want to apply all of this to the test data set so that we can generate a submission. All the pre-processing is exactly the same as per the top part here, except we won't need the partitioning because we are doing a prediction on the full data set. So now let's add a decision tree learner, and in this decision tree learner we are setting our minimum number of records to 6, as that seems to be the optimal solution for now. Let's train our model and let's run our prediction. And there we have it. Our prediction is ready. So now what we want to do is we want to get our prediction into the submission shape. So we need to get back in the passenger ID, and we need to rename our predicted survived column to survived. So let's add some more pre-processing nodes. First of all, a column filter where we only keep the prediction column, and then we use a column appender to put together passenger ID, the true score of survived, and our prediction. And then just because the survived column is integer and the prediction survived is string, we turn this column into a string with the number to string node. And now we can do a couple of things. To start with, we want to score our submission. So we again have survived and our prediction, so we can put that into a scorer. And here we can see that we predicted that 25 people survived that didn't survive, and we predicted 11 people not to survive when they actually survived. So that's an okay score, I guess. So next we add a table manipulator, which removes our survived column and renames our prediction survived column to align with this format so that we can submit it. And then we have a CSV writer that that we can use to write a CSV file. So now that I've written that CSV file, let's go back to Kaggle and let's do a submission and let's see how we are doing. On the leaderboard side, you can see the submit prediction button. If I click that, I can browse to my files. This immediately gets me to my Titanic workflow folder and therein to the data folder where I've saved my submission version decision tree to, and I will select that. And that then checks that the format is correct. And after clicking submit, we are actually good to go. Wow, with a score of 0.75. So let's jump to the leaderboard and click on jump to your leaderboard position. So we are still pretty much down at the gutter at around 12,847. But I think that is not too shabby for that. We did this in just a few minutes with very, very simple pre-processing, like taking the median age for all those passengers where we didn't have the age and so on and so forth. So I think there's a lot of potential to improve this score throughout the year by doing better pre-processing, by applying more advanced algorithms like random forest and so on and so forth. But yeah, that's a story for another time. From time to time, I will do a video where I'm doing something different and will look into how I can improve the score. Let's see how close I can get to that perfect score of 1.0 throughout the year of 2025. Thanks a lot for tuning in, and I will see you next time.